Okay, this lesson will cover multi-dimensional arrays. Let me start with two-dimensional arrays. So two-dimensional arrays, we may have two indexes. One refers to rows, the other one refers to columns. Single-dimensional arrays, we had one index. I may say that was a row index. Okay, let me visualize it. So we have an array reference variable. Two-dimensional array looks like a small matrix or table, consists with columns and rows. And then each the space, or what we call as cells in Microsoft Excel, we may refer to that particular locations using index that refers to row and columns. Let me put some examples. Let's say 1, 2, 3, 4. So we have a series of integer values 1 to 16. Each value can be located using two indexes. Okay. So here we refer to row index. This is refers to column index. Again, we have 4 rows and then 4 columns. So let me just say X. Here again start with 0. Index value that refers to rows, 4 rows. Again another index value that can be used for the columns. So start with 0 and then again 1 and 2 and 3. So value 1 can be referred to index variable 0 and 0. Say my array, we are using brackets 0 and 0. So first index value 0 refers to row, second 0 refers to column index. So if we assign new value 10, that will be the location. So if you look at here, my array 3, 1, that refers to number 14. So look at the index 3 of row and then column number 1. So we are referring to integer value 14 here. So let me show you the syntax to declare and create a two-dimensional array. So first one is declaring a two-dimensional array reference variable. So we are going to use two brackets instead of one. So two-dimensional array, we need to use two brackets. Each of them refers to a row and column. Or you can say the first dimension and second dimension. The second one, we need to construct a array data structure. In this case, two-dimensional array data structure. So we are going to use a keyword called new. So reference variable, new, data type, size, array size for row, and then array size for column. Then assigned to a reference variable using equal sign. Again, we can combine together so that we can make it as one statement. So we can combine declaration and creation in one step. So data type reference variable equal new data type, and then make a decision for row and column size. Okay, let me look at the example here. So I will say matrix four by 3, so that we can see the difference between column and row. Again, we can use old style, which I don't really recommend it. But if you look at the old source code, you may see some sort of old style declaration, so you should be able to read it. So brackets is the next to array reference variable instead of next to data type. So basically same thing. Okay, let me visualize it. So we have 4 columns, and we have 4 rows and 3 columns. The first number 4 refers to row, second number 3 refers to columns. So we are looking at the integer values. Let's say you are going to add number 10, 20, 30, 40, 50, 60 in order. Then I will show you how to assign that value. Because initially it's integer values, everything has a default value 0. Now what I'm trying to do is let's see whether we can assign new values. using the particular locations. Again, index for column is 0, 1, 2, 3. Sorry, index for the row start from 0, 1, 2, 3. Index per column start with 0, 1, 2. So if you want to assign number 10 in that particular locations or position, we say matrix index 0. That is actually row index, and then column index. That will give us number 10. Let's look at the number 20. Again, it's the same row, so it should be matrix 0. Will be next column, so number 1. Then assign 20. Again, next one, still same row, 0, and then number 2 for the column index. And then, let me just do repetition again, just in case. So we just finished the first row. Let's go to second row. Second row is matrix 1, and the first column is 0. We can assign number 40. Again, we do the same thing. 1 and 1, 50. Then 1 and 2, 60. Again, I will continue. Okay, that was the last one, 120. That's how you assign the value from 10 to 120 to two-dimensional array using assignments and its row and column indexes. Let's look at the size of this two-dimensional array. What if I say matrix dot length? Same as a single-dimensional array, we are referring to rows. So how many rows do we have? 0, 1, and 2, and 3, 4 rows. So that will be number 4. What if we want to refer to the first row, which is 0, and then dot length? So basically say on the first row, how many columns do we have, or we can say how many elements we have. So we have 3 elements, that means we have 3 space per columns. So answer is 3. Let me repeat the same thing for matrix 1 dot length and 2 dot length, 3 dot length. All of them has 3 elements each. So answer is 3. This is important to say is that we can process the row 4 times, and then each row we process, we may need to repeat 3 times for processing columns or elements located in the columns. So we may need to use a nested loop, basically two for loops, to process 2-dimensional array. What if you know the initial value at the beginning? So you can declare with the initial values. So let's say same thing, int matrix. I will try to use the same visual or same idea. So opening and closing, we are using curly brackets. So we have 3 elements, so 10, 20, 30, using comma. So that represents first row with 3 elements, and then second row 40, 50, 60, they represent second row, comma. Then I will continue for next 2 rows. Again, last row, you don't need a comma at the end. Again, let me make a minor arrangement here. So if you look at here, it looks like a table. For rows and then 3 columns. Of course, you don't have to do indentation this way, but it's actually a lot easier if we follow the same indentations. That maybe looks like exactly the same as a matrix in terms of visual, or you can illustrate it that way. Let me quickly demonstrate a 2-dimensional array in Java. So this is tutorial number 33, 2-dimensional arrays. Again, let me use the small one. So we have a 4 by 3. Declare array reference variable with the integer data type. Then you can create array reference variable using new keywords then you can assign to matrix reference variable. Int and then space 4 by 3. So that new int 4 by 3 will construct a data structure consists with 4 rows and 3 columns. Let me manually add values one by one. Let's say 10. We are looking at the same row and then next column. We have a 3 columns, so 0, 1, 2, 20 and 30. We have 4 rows, so let me have a matrix 0, 1, 2, 3. So I will continue for 3 more times. So this is second row. Value should be 40, 50, 60. Next one should be third row. That will be 2. The value for third rows 70, 80, 90 for columns. And then let me do one more time for last row, which is a matrix 3, and 0, 1, 2 for 100, 110, 120. So that's how we create two-dimensional array. Let's see how we can process, but let me show you one thing first. There's another shortcut called sout. It will give you a system of print ln. It will speed up process because we use it all the time. So let's say sout. You type sout, press tab key quickly. Let's look at the matrix dot length, size of this matrix in terms of rows. How many rows do we have? Or we can say the first dimension of this two-dimensional array. So we are looking at 0, 1, 2, 3, which is going to be 4. Or we can say that how many times do we have to process for columns? Sorry, rows. We say 4 times. And then each rows we have 3 columns, isn't it? Yep. So if you look at here, we have 3 elements. So if you do the same thing, second row length is going to say 3. 3, okay. That is important information we need to process two-dimensional array using 2 for loops. So we need to have 2 indexes. The first index may deal with a row. We call it as a row indexes. I will say I, 0, 1, 2, 3. We need column indexes. I will say J, 0, 1, 2. So how do we print two-dimensional array here? So we are going to use a for loop. So exactly same as process single dimensional array. Int I equal to 0, and then matrix dot length until last one, and then one by one. Then when I is equal to 0, we need to repeat 3 times per columns. So we need to say that matrix I dot j increase by 1, start from 0, 1, and 2. So matrix depends on I. When we continue until we reach the last columns, which is matrix I dot length. So we are talking about, let's say when I is 0, we repeat 3 times per columns from 0, 1, 2. So we print, what are we printing? Actual value according to matrix I and j. So basically saying when I is 0, we print columns 3 times and increase by 1 for I, so we print another 3 columns, and then we increase I by 1, print another 3 times, and so on. Okay, let's see what happens. Don't worry about spacing. But if you look at 4 and 3, again, don't worry about that 4 and 3. Basically say we have 4 rows, each row has 3 columns. So this is important thing, 10, 20, all the way to 120. So we can print 100 all the way to 120. So let's look at it. Can we actually break after processing 3 elements? So if you look at the embed for loop that control columns, so after we printing columns, we may put a new line. Print array will give us a new line with a blank space. Okay. So 10, 20, 30, again, that is 10, 20, 30 without space. So let me just add 1 space. Each time when we print elements, we add 1 space. So that way it's going to be more visible, or readable, sorry. So now we have 10 to 100. That's exactly same. So we just cover how to process two-dimensional array. You need to use 2 indexes, index for row indexes and then column indexes. And this particular ones, we are processing rows according to, we are processing rows from first one to last one. When we process each row, we are going to process the 3 columns. So basically, if you're using 1-dimensional, you need to have 1 for loop, 2-dimensional array, 2 for loops. So now you can guess, 3-dimensional array, you need 3 for loops, and so on. Again, here, just look at the loop carefully. If you are looking at the first time, it looks complicated, but if you draw it on your paper, it will make it a lot more easier to understand. So I referring to rows here. When we process each row, we are going to process the columns too. And then I just create a new line or next line to make it more readable. Let me think about, okay, what if we know initial values at the beginning? So let me quickly cover that new syntax. So here I will make it comments for all of them. Yeah, all the way to, yeah, that's the one. Comment. Then here int so here int matrix. Then I'm going to do same thing. Then we need to use a curly blanket for each row. Inside each row we can use the multiple values by separating them with a comma. So first row, second row, 1, 2, 3, 4, that's it. And then change to 40, 50, 60, all the way to 120. And that's it. Everything else is exactly the same. Again, same. Again, that's all. Thank you. Again, same. Again, that's all. Thank you.